I'm sorry.
Sine wave you clicked, that magnitude should be selected or no? Hello, madam. I am Dr. Baswaraj Tigde.
Correct, sir.
Calling from Belagavi.
Yes, sir. So,
input sine wave amplitude should be selected because if the input sine wave is less than the cut-in voltage of this diode, the diode will not conduct.
Correct, sir. But if you go through the theory and then follow this one,
that's why. So here, how to select the sine wave?
So we just have to click on a sine wave. This is a basic lab, sir.
Yeah, basic lab sine wave should be that magnitude, amplitude should be there, no, madam.
So frequency and amplitude variation is in the below, sir.
The control section, sir.
Control
section. It allows you to change the frequency and the
as well as amplitude as well as
and even the phase shift.
Yes, sir. That's what. Yeah.
Yeah. This is
Madam, how to undo the connection, madam?
Okay, there are two types of circuits here. One is this is sir is select. So there is one more option in the lab itself where you can, like I did in the Ohm's law, you can just do the node. Like you don't have like in there are advanced labs, not in the basic electronics, but other places where you can select the equipments. Here everything is fixed. You just have to connect the nodal connections, like I did in the Ohm's law, sir.
Excuse me, madam. Here, by default, maybe silicon diode is taken. I think maybe.
Yes, sir. It is a default diode.
Yeah. Okay.
Madam, if we are doing the rigged up the circuit here in
yes, sir.
lab, but I have done a wrong connection, so I wanted to undo it.
Correct, sir. Yeah. Okay. It is possible. You can click on that node. Can you share your screen, sir?
Oh, shall I?
So yes, sir. Please, since your experiment is almost done. So thank you, sir. Thank you, sir.
Okay.
So I request sir to share a screen. Asif, your mic is on.
Madam, this connection I want to remove.
I'm sorry?
I want to remove this connection from 1 to 3.
Yes, sir. I cannot see your screen. So you will have to present it. So are you presenting? But I am not able to see your screen. So can you represent the screen, sir?
Yes, madam. Right.
And select the window.
I request Mr. Asif Iqbal Mullah to please switch off your mic and switch off your video as well.
Madam,
thank you, sir. Yeah, Vinod sir, we are not able to see your screen.
Okay, Vinod sir, I'll address your doubt first. I'll show you. Okay, your screen is presenting now.
This connection, madam, 1 to 3. I need.
Sir, you'll have to select a command window when you press. When you either select a window or an entire screen. Then we'll be able to see your screen, because as of now we cannot see your screen, sir. When you present, click on present and either you can select entire screen or else a window.
Okay. Madam, kindly please see if is it visible?
No, sir. So I'll just show. I'll present and show you how to undo it.
Kindly go ahead, madam. Thank you.
Yeah.
Madam, 2 minutes. I wanted to. I'm just trying Thévenin's theorem.
Yes, sir. We'll get there, sir. Yeah. To that lab next.
Madam.
Yes. So I'll just answer Vinod sir.
Madam.
Yes. So I'll just answer Vinod sir. Okay. I can.
Now it is visible.
Not visible, ma'am.
Now, okay, so I've taken you to Ohm's law, I believe. One of the participants, madam. Veena ma'am. Harish sir, please switch off your mics. Yes. Okay, so now that I've made a connection, so if you click on this, all the participants. So I think my screen is visible with the Ohm's law circuit.
Requesting all the participants to please mute your mic.
Okay. So I'm addressing to the how to clear the connections. You just, I request the participants to please switch off their mic because my voice is echoing there. So just to clear the doubt, you just click on this node 3. So all the connections that I've done to for the point 3 can be removed. Or else there is one more option where all connections here, delete all connections. Just say I have connected everything here. So for me to remove 4 node connection, I'll just click on 4. So all the connection relevant to that node is gone. Or else you can do one more thing, that is delete all connections. When I delete all connections, all the connections that I have done until now is gone. So that should address both of the questions, I believe. And for one more question that earlier one of the ma'ams asked me is how to vary the resistance value. Ma'am, if you can see in this here, there is controls. In most of the experiments in this lab, we'll have something similar to this. As you saw in the half-wave rectifier as well, you just have to scroll it, ma'am. And you can see here the voltage value has been changed to 14 volt. Similarly, you can do the resistance value. So here you can see that resistance value is changed, but the current depending on what we choose as a resistance and the voltage. So it is a inbuilt developed only. So you cannot change the current value because then only we can draw the VI plot. So that should answer most of the doubts that has been raised here. So is that?
Madam, in the rectifier experiment, there is no space for delete all connections. Like
Because
what
in the rectifier, if you see, sir, there are 2 types of circuits, sir. So one is directly rigged up circuit. You don't have to do anything related to circuit there. And then when there's one more circuit where we have an option of rigging up the circuit as I did it in the Ohm's law. So if you go through the simulation, there is draw circuit.
Draw circuit you have to go. Okay.
Then you can do the node connection. So here, that is what it is, sir. So
I'm from KIT Chittoor.
Yes, sir. Thank you.
Thank you, madam.
Ma'am, in half-wave rectifier, there is no option of dual getting enabled, no, ma'am. How to enable
it's
that?
there, ma'am, in the dual.
It is there. I mean, we have channel 1, channel 2, ground and dual. How to get enable? Like, if I click also, it is not.
Dual
It is not enabled.
Maybe you have not clicked on oscilloscope. If you click on the oscilloscope, only then output will be displayed. Then only you can click on dual and you'll get this one, ma'am.
I just varied the resistor value and I'm trying to click the oscilloscope. That is not getting clicked. In the sense, it is not getting enabled. So where I might have to just, frequency amplitude off button is there. There also.
No, ma'am. You have to switch on here.
Switch on.
And
I
then
switched on.
Sine wave.
Okay, resistor value is changed to 500. Then again, there is a OSC oscilloscope. There I'm not able to. If I click also, it is not enabling. Sine wave also.
Ma'am, I'm presenting my screen, so I am able to do that.
But madam,
Yes, ma'am. In your it is clear like the sine wave oscilloscope is there.
Maybe you have to. Maybe you have to refresh your screen, ma'am. At that time, maybe due to some network issues, things might have not shown up. So you'll have to refresh your screen.
Okay.
Their print option is not there, in offer rectifier. That print option, madam.
No, sir. But calculation option is there. So you have a calculator, and you'll have to calculate the peak value. So looking into the VM peak voltage, and so only you cannot do that, but you can do the take the snapshot or so to get the print screen, sir.
Okay, fine, madam. Thank you.
Yes, sir. So that can we move? Yeah.
Can I demonstrate Thévenin's theorem for you?
Sir, I'll take you to that, sir. Now I'll take you to advanced network, analog network and measurement lab. So can I continue with my experiments now?
Yeah, madam.
Thank you. So this is Analog signals and network, as you can see here, this is the lab here, analog signals and network measurement lab. And so we have a same thing as we have seen in the earlier lab, list of experiments. Go to the list of experiments. I'll take you to Thévenin's theorem. So we have a theory related to the Thévenin's theorem. This is a circuit which we will be operating in the simulation as well. One thing that is to be remembered is we cannot change the number of resistors and voltage, voltage selected. We cannot change. It is a fixed circuit. There are other labs in the electronics and communication domain itself where you can change the use different set of resistors, but here in this it is a fixed. So this
Here
is
we
operating
have cases in the simulator.
Yes, I'll take you to that. I'll go step by step. So okay, so this is a procedure relevant to this particular experiment. So this will be your circuit, and this is how the calculations as well as how we perform an experiment in this simulation is explained. So now I'll go to the simulator. So here I've already opened the page. Okay, an error. So can you present your screen, sir? I'll take you to that.
Can I present my screen? Can I present
Stop sharing. I'll stop sharing. You can present your screen and I'll take you through that experiment.
Yeah, madam. I am just presenting, please.
I stopped my presentation because I am not able to enter to that page.
Okay. So I'll share. Can I start sharing my screen?
Please, sir. Please do that.
Yeah. This is what we call this as this Thévenin's theorem, as madam is saying. This is
okay, sir. So you can click here to perform. Okay,
yeah, verification of Thévenin's theorem is this here.
So this is
case one.
Yes, sir. No, sir. I'll start with the case one. So this is a conventional method in the case one.
Yeah.
How we perform an experiment. So if you go to that power, that is switch one.
Yeah.
So click on that. Power, short, intermediate. That is the options. So you don't click nothing. Right now, let it be as it is. I'm just giving a detailed version since I cannot get my page. Okay. So then if you go to the V1, you click on that V1, sir.
V1, here. Or,
anywhere, sir.
Yeah, here, V1, yeah.
So you can see that you can vary the voltage. So as I mentioned earlier, the circuit is constant. That is 3 resistors have been selected and that is how it is connected. So yes, sir. Similarly, if you click on R1 there.
Yeah, R1, yeah.
Yes. So you can vary the resistance value.
Okay.
So similarly, R2 and R3 can be done. And there is one more switch provided. So
this
also has a drop-down menu, which is we can select a so on, intermediate. And then there is an RL, so a load resistance there. There also we can vary the values.
Okay.
So now we have an ammeter and voltmeter also connected here. Okay. So as per the procedure here, keep all the resistance close to their respective maximum values. Choose an arbitrary value of V1 and V2. We have done that. Now in case 1, select switch 1 as power. It's already done. Switch 2 as load. So if you could go to switch 2, and it is in load. Change anything since we are proving Thévenin's voltage here. So now, sir, you can click on simulate.
Okay. 78.750.
Yeah, so that is the Thévenin's voltage. Now, sir, if you go to case 2B.
Okay.
So now we'll find Thévenin's resistance. So just one thing is, if you follow the procedure properly, there won't be an issue while performing a simulation. So as per the procedure, it says that apply S1 to short. So, sir, if you could switch 1 to short, click on short. Okay, and then it says switch 2 to power. So power. Yeah. Now we have done that. Now click on simulate, sir. So this is the voltage V2 value noted, current value is noted, and Thevenin's resistance is noted here. Now if you go to 6.3, sir, case 3.
Madam, can you please explain what is power intermediate?
So those are the options that you can select, sir, depending on what you're finding. If you're finding going to find Thevenin's resistance, you will need switch one as short. We'll short it. So as per the theory, how you find Thevenin's voltage in this circuit, that is what we follow, sir.
Now, what is intermediate?
So
Intermediate the switch, what is the issue, madam? Price stating or what?
yes, sir. So it's in the theory, sir.
Okay.
So this is the.
In digital, we'll get a tri-state. Tri-stating means it is neither 0 or 1, like that it could be. I don't know. Some theory.
Okay. So now, so the same thing. If you go to case 2A, and we have used this is a basic final circuit that we come here in the case 3. We say that final circuit. Can we? Yeah. This is a conventional circuit which is converted into Thevenin circuit, that is resistance voltage in series with the load.
Okay.
The load is same, you can see that, and that whatever case 2A and case 2B value used, and now you can click on simulate, sir.
Okay.
And it proves that if you go to the case 1,
Okay.
load current is proven.
Correct. 0.601.
Yes, sir.
So in case 3, we are getting the same.
Yes, sir. Now if you click on fill the data in the table.
Okay. So we'll go to table. Okay.
Yes, sir. Fill the data. So click on fill the data to the table.
Data, where it is now?
Below the simulation, so in the case 3.
Yeah. Fill the data to the table. Okay.
So similarly, you can change the resistance values and find a different. But one thing, yes, one thing constant here is you cannot change the circuit here.
Circuit, yeah. Suppose we want to change the circuit, we have to again use the simulator and build the circuit and.
Only you can change the resistance value as well as voltage value. You cannot change the circuit in this particular lab, sir.
Okay.
But there are labs where you can change the resistance, different types of resistance. You can rig your own circuit, which in next my colleague will present, where you can do all those variations as per your requirement.
Okay,
so
nice. Yeah.
Okay. So this is if anyone else wants to present this one, they can present.
Yeah. Okay, I'll just stop.
Yes, sir, please. Sometimes, as I faced an error, you will face such errors like 503 service unavailable. But later on, same day, they'll try to fix the issue, and you'll be able to access those labs. So I was facing an error as such, so I asked sir to present.
It's okay. Thank you, madam.
Yeah, thank you, sir. So is there anyone who would like to take up one more experiment in the same meaning? So most of the experiments is similar to what shown here.
Hello, madam.
Yes,
we are also facing the same error now. We cannot open the analog lab.
Yeah, okay. Maybe because most of us are using, that is the reason. So if you can try in maybe later today or tomorrow morning, that lab will be operative, sir. So that is fine. So
hello, madam.
Yes,
madam,
sir.
this is from GSS Engineering College, Mysore.
Yes, sir.
Madam, to go for advanced communication lab, to do advanced communication lab experiments, I went to that vilab.co.in.
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 Correct, sir. Okay. Yes, sir.
Then labs ready for use is there, and right side IIT Kharagpur, IIT Roorkee, IIT Hyderabad, IIT Delhi.
Correct.
So if I want to go for advanced communication lab, here it is not mentioned. I want to go with IITs.
No, sir.
Where I need to search,
so there are labs even in the new lab development page. there are under new lab development page, which we will take you to in the next session, sir. So, but like depending on if the lab is live or not, it depends on all whether sometimes some labs might not be available in this electronics and communication, but it might be available in electrical domain. So you will have to browse to go through the VLab portal properly, sir. Few labs, since we share it with computer science as well as electrical, since it's common, it will be here and there. Also, there is an option for new lab development, and under that there are lab under development or which is already developed, so which is not yet published in the main website. So those are the things. You will have to go through the labs properly, sir. Browse it to find the particular experiment that you are looking for. So we have more than 800 labs as of now. With around so more than 100 labs with more than 800 experiments currently live. So little more searching would require, sir. So that
Small doubt. Even I put it in the chat box. How to remove how to keep the connection between nodes, madam?
I had demonstrated twice, sir. You just have to click on the number, sir.
Madam. Okay.
That is it. If you see. Okay,
madam. Thank you, madam. Thank you so much.
Thank you, sir. Thank you.
Ma'am, lab under maintenance is, excuse me, ma'am. Lab under maintenance are not opening. Maybe in future we might. And what about the software related labs, DSP, HDL lab, such kind of this one?
Couple of software related labs will be. Couple of software related labs will be taken in the afternoon. Just
there is a software virtual lab, some networking lab is there, madam. That is another lab.
CCN, VLSI lab, all that.
Yes, ma'am. We will. We have currently we have decided on a flow, ma'am. So that is why we are taking through on a flow that we have decided. While taking up questions, we'll also try to answer your questions, ma'am. So
ma'am, I tried to disconnect from the note side, but I'm not able to do it. Shall I share my screen?
Can you present? Yes, ma'am. Please present your screen. I'll talk you through that.
Is it visible?
No, ma'am. Like all of us are not presenting, so you'll have.
Ma'am, I tried to disconnect from the node, but
Ma'am, click on present screen and click on the window, ma'am. You are using your system, no, ma'am?
Yeah, present now. I'm going. My entire screen.
Click entire screen. You can do that.
Yes. 1 second, it is getting now.
Click on that and then share.
It's visible now?
Okay, now you are presenting. Yes, ma'am.
Yeah.
So whichever.
See, I wanted to disconnect from, for example, channel 1.
Yeah, click on 1 there. You can see the number 1, no, ma'am?
Yeah.
No, ma'am. Number. You have to click on the number, not on the node.
Number.
Yeah.
Thank you. Okay.
Thank you, ma'am. So that is okay. So yeah. So now I'll request my colleague Shrestha to take over the presentation. Shrestha, you're available?
Hello, ma'am.
Yes.
Hello.
Yes,
Hello.
sir.
Ma'am, can we give the input voltage in terms of millivolts?
So this is a basic lab that I demonstrated. So much changes you cannot. If the lab permits you, then you can. If the developer has developed this labs in such a way that you can change the millivolts, microvolts, then you can. But I guess whichever lab you are operating, you don't have that option. Which lab are you talking about, sir?
Ma'am, I was just carrying out this experiment on operational amplifiers. I was doing that.
Same thing, basic electronics lab, no?
Yeah, basic electronics lab.
I don't think so. You have an option to change it voltage, whatever the fixed set of values that variation is shown. That much you can change. Further changes, it's not that lab won't allow you to do that. So
the minimum that we can give is 1 volt. That's it.
Correct, sir. That is it. So that is.
Thank you.
Yeah, thank you, sir. So Shrestha, Will you?
Yes, ma'am. Yeah.
Okay. Thank
So
you,
if my
Shrestha.
voice is clear and audible?
Yes, Shrestha.
Yeah, thank you, ma'am. So a very good morning to one and all present over here. Myself, Shrestha, working as Senior Research Fellow at Center for System Design and NITK Surathkal. So here are a couple of questions in the chat box. Also, like if I look into the flow, I prefer the participants only if the question is so mandatory, you can ask in between. If not, it's better. I feel it's better we go with the flow. Then maybe towards the end of the session, we can keep 5 or 10 minutes for the uh, Q&As, question and answers. Okay. So meanwhile, if you have any queries, you can put in the chat box so that the flow will not be interrupted. We will be answering the questions as and when we follow the chat. So that it will be convenient for everyone to be in a flow. Okay. So to start with, so you had one hour session from Professor G.V. Gangadharan sir initially. So even Shraddha ma'am had introduced a couple of labs in the core electronics and engineering domain, right? So now let me share my screen. And one more thing. There was an issue with respect to the labs of IIT Kharagpur. At IIT Kharagpur in the afternoon session. Okay, so now currently let's see if you have the labs developed by other institutes. So we have, as a participating institutes, we have 11 altogether, right? So we will see the labs developed by other institutes now and move into the IIT Kharagpur labs later on. And as you can see in the electronics and communication domain, one of the main parts developing institute under electronics domain is IIT Kharagpur. So let's see later on. So with that, let me share my screen. Hope my screen is visible. It is loading. Okay.
Yeah,
Hope my screen is visible. Okay,
visible.
fine. Okay. So I would like to summarize few of the points quickly that has been discussed by Gangadharan sir and Shraddha ma'am. So these are the objectives, philosophy, always are fine. So this project, virtual lab project, when we say it was started long back in 2010, and it is continuous evolving project even now, right? So as told, we have around 800 plus experiments available in the portal now, in the main portal, and there are many more gap areas that has to be filled. So as an example for that, communication lab, what you are asking for, in virtual lab platform, there are no labs currently for communication, that is analog or digital communication, that is with respect to modulation or ASK PSK. Currently there are no labs available, so it is yet to be developed. Okay, so today basically let's see the different type of interfaces what we encounter with respect to the labs. Fine. So virtual lab, when we say, it is a 3P lab, that is independent of place, space and period. Second point would be, it provides a complete learning management system at a single point. Yeah, so these 2 points are the important points to remember when we say virtual lab. It is completely free to use. It is not a software, it is a website. And here you can see these are the 9 different broad areas over which virtual labs have been developed. And these are the participating institutes responsible for the as well as outreach. Okay, so development as is with respect to the development of labs that is available or yet to be developed, and outreach, when we say, it is spreading about the awareness of this particular platform or availability of the resource. So to move on, these are the 9 different areas over which virtual labs have been developed. So here I would like to stress on 2 points. One is, when we say a lab, or if we take a concept, say, which is common for different domains, so you might find a lab for that particular concept in one of the domain. Okay, so for example, logic design, if we take, it is common for electronics, electrical, computer science and so on. Everybody will study. the lab we might find in one of the domain. So we, being the users, we need to explore the different labs available and pick whichever lab is suitable for us. We need to explore the domain and pick the suitable labs. That is one point. Second would be, we might find the experiments demonstrated under multiple labs. So whichever interface we feel convenient, we can pick that and use it. Okay. So if you see circuit domain, here there are two options available. Right, in couple of labs under electronics and communication. Let's enter into that. It is loading. Fine. So hope my electronics and communication lab list is visible. Uh, okay. My voice is not clear now. Is it clear now?
It's clear, madam. It's audible. It's clear.
Okay, sir. Thank you.
It's clear, madam. It's
Okay,
clear.
okay, sir. Yeah. Hope my screen is also visible.
Yes, it's clear.
Okay.
Yeah, screen is visible.
Okay, sir. Yeah, fine. Yes. So to move further, here you can see labs from very basic topic to very advanced one, right? So everybody were asking whether we can rig up our own circuit and apply the concepts over here. So for that, you have seen an experiment under analog signals, network and measurement lab, right? So there is one more lab called electric circuits lab from Amrita Vishwavidyapeetham. So both these labs work on, the experiments are based on theorems, laws, and so on. So you have already seen one lab where the circuit is fixed. You can only change the component values and get different observation sets. Right? But over here in the second lab, that is electric circuits lab from Amrita Vishwavidyapeetham, you can rig up your own circuit and get the output. Fine. So here these are the experiments available. So one more thing to stress on virtual lab platform is, when you say a lab in your college, all the experiments might not be listed in under same lab in virtual lab platform. So this was one of the question by the people who were viewing YouTube live stream. So can we customize the experiments under single lab? No. Currently in under virtual lab platform, there is no provision for customization. So the experiments what you feel you have in one lab might be available under multiple labs over here. Okay. So maybe we can create a Google sheet also. We can paste keep the link of its
Ma'am, I think your network is not proper.
over there, and then we can share it with the student. That is one of the options. So to look
Excuse me, madam. Your network is not proper, I think.
the thing,
Audio is
so
not clear.
here an experiment over here. Let me again go over here with Thévenin's theorem experiment only. Also, is my voice is clear now? Just give me a second. Is my voice clear now?
No, ma'am, it's not very clear.
Okay. Hello, is it clear? Okay.
Now it's clear,
let-
ma'am.
Okay. So if any further interruption happens, let me know. So I think then at that time Shraddha ma'am can take over the session and I'll rectify my internet connection and come back. Okay. So now let me continue. So hope my screen is visible with Thévenin's theorem experiment. So this is the theory procedure. All the content covered would be similar. Okay. So it asks for login. So is login in is compulsory for each? So is it necessary to log in? For that, with the labs developed by IIT Kanpur and Amrita Vishwavidyapeetham, when you try to access the simulator, it asks for login. Okay, so you can just create your account and using your login credentials, you can keep using the simulator available whenever required. Fine.
This is our university.
Okay, so I have already created my account, so I'll just log in. So using this login was started initially to just keep a track of how many users are using this particular experiment. So you can just create your account and use. And when you go for the simulator, would require some of the basic plugin to be installed. Okay. So the previous two labs showed it works with your mobile phones as well. But this particular lab requires Adobe Flash Player allowed by the browser. So I'll allow it to run. Okay. In case if it is blocked, then you can go here. You can make the settings allow over here as well. It would be initially blocked. You can allow it. Okay. Fine. So now I got access for the simulator window. Here we can rig up the circuit using the components available. Then measure the parameters with the components available. So to rig up the same circuit, I can just click on the component, drag and place it over here. I can change its orientation. I can here battery is available. Then we can connect each of the component using wire. We need to drag the endpoint of wire to make the connection. If the connection is complete, it will be shown in black color at the endpoints. So if it doesn't show black color, it means the connection is not complete. So please look into that. So once you do the connection, you cannot move the components anywhere. So once we have entire connection rigged up, we can now measure, like if you want to measure the current or voltage across some component, or we want to measure the current in one of the branch, we can take the components available and do that. So I'll take non-contact ammeter and place it on in this particular branch. It shows 0 ampere as the current. Okay. So now we don't know what is the value of resistance and all. So for that, first I'll click schematic. Yes. Now I'll click on show values button. Now I'll be getting all the component values displayed. So now if I want to modify individual component value, then I can click on that and vary over here. So according over here, also the parameter like output parameter value also will vary accordingly. So if I want to measure the voltage, I can get the voltmeter, connect across the terminals, and I'll be getting the voltage. Okay. So currently we have 9-volt battery and we are getting the same in voltmeter as well. So this is how the experiments. So just as a feedback, is my voice is clear now?
It's audible, madam.
Okay, fine. Yeah, thank you. So if you note over here, all the experiments in one particular lab will have a similar interface. Or to be more specific, maybe the lab structure will look similar with institute. So lab developed by IIT Kharagpur will have one interface. Lab developed by NITK Surathkal will have different type of. Each lab might have its own type of experiment interface. Okay, fine. So other experiments under this particular lab will also have a similar interface for the experiments. So how to unblock Adobe Flash Player? Can you share your screen, ma'am? Tripti? I'll stop sharing my screen. So I think some other participants will also have a similar problem. It differs from system to system.
Yes, ma'am. Here, I'm not able to unlock.
Okay. Yes. Okay. You can see your screen now. At the top, where we write the link, to your right, to the right corner, you have a symbol with red color. Yeah. Click on that. Go to manage. Click on manage option. It will take you to settings page of the browser. So there we need to enable. There is block sites from running Flash. So yes, just enable that. Now go to the simulator window. Now click on that. Click allow.
Yeah,
This
thank
is
you so
one
much.
of the options to unblock Adobe Flash Player. So hope like other participants might also have a similar problem. So this is how it works.
Yeah, thank you so much.
Yeah, yes, ma'am. So hope it is clear. Okay, and is the simulation flow is also clear to everyone? If you're trying out parallelly, hope there is no problem with that. So I'll go with the next lab demonstration. Maybe let's see one or two lab and then go with the hands-on. Okay, fine. So now let me share my screen again.
Madam,
yes, sir.
Madam, in my screen it is saying that up to December 20 only the Flash is available. After
Yes,
that, there is no support.
Yeah. So actually, these labs, as I already started the development was started long back. So these experiments were being developed from 2010. So at that time, Flash was one of the easiest plugin that could be used. So now in 2020, it is being changed. So now the recent labs or newly developed labs are working without Flash Player as well, and the experiments that is using Flash Player are being updated. Or upgradation is going on with the experiments that is using Flash as well now. Okay, so for that reason only, when you try to access some of the labs from some of the institutions, it might be the server might be down. That is just some upgradation. So when you try to access some of the experiments, it might not work at that particular time. So whenever you encounter such cases, if the lab is not opening, if some of the experiment is not working, then please hold on, wait for 2 or 3 days, maybe at the max for 1 more week. Then just try on to work with the same experiment. Even then, if the problem persists, you can write to us. So we will be sharing our mail ID, official mail ID. So you can write to us. You can write to us. In that case, we can convey that to the national coordinator team and they can rectify that. Okay, so I think unblocking Flash Player was demonstrated now. So hope that was clear. Veena ma'am, I request you to try on. So you need to go to the browser settings page at the top, and then you need to enable Adobe Flash to run. Then once again, refresh your simulator screen, then you'll be getting the access. So if it is not clear, you can quickly share your screen and have a look so I can help you out. If not, you try it on your own. We will have one more lab demonstration, and then if the problem persists, then let's see, ma'am. Okay, so let's move on. I'll present my screen now. Okay, we were in Thévenin's theorem, right? I hope my screen is also visible now. Okay, it is loading. Hope my screen is visible now. Okay, thank you. Fine. So I'll go back to the main website now. in broad areas. Now let's see one of the experiment. Okay, so before that, let me check if the IIT Kharagpur labs are up now. If yes, then let me take you to digital electronics lab. Okay, it is even now. It is not up. Let's wait for a few more time. Before that, okay, I'll go back to the main site. I told there is one like there are few of the concepts explained in different domains, right? As an example for that, I'll take you with one of the lab under computer science and engineering domain. Okay, so there are labs which are core to computer science and engineering, out of which you can see here there is a lab called computer architecture and organization lab from IIT Kharagpur, right? So let me get into that. Okay, it is again developed by IIT Kharagpur. Okay, it is again developed by IIT Kharagpur later on. Fine. To move on next, this is with respect to the main website, right? So let's see the labs available under this in the afternoon session again. So now let me take you to one more place where we can get other labs. Okay, so for that, this is the main website what we have. The link is vlab.co.in. Over here only, at the top, you can find there is an option called new lab development, right? So if we click on that, it takes us to one more. Okay, so it is new lab development, but so it will take us to this particular website. So here at the top, you can see something called explore labs, right? So here there are two options. One is approved labs and one more is labs under development. Yeah, so these two options as well, when you go within that, you will find set of labs relevant to our domain. Okay, so let me now move to approved labs. So what are these? So these labs, are they listed in the main website? No. So this particular lab is not maintained. These labs are not currently available in the main website. It is yet to be added. Okay, so these labs have to be completed with a number of experiments. So for example, if I want to take microcontroller lab, at that time somebody was asking for a microcontroller interfacing with Gangadharan sir. So let's see the lab 8051 microcontroller available over here. Okay, so let me get into that. Fine. So it is developed by one of the nodal centers of this virtual lab project. Okay, so currently these three are the experiments available under 8051 microcontroller lab and many more to be added. So once we complete the set, then this lab will move to the main website. So before that, it will be available over here. Okay, so let's see one of the example over here. So let me take you with a microcontroller interface with display devices experiment. That is the first experiment as an example. So again here the content covered would be similar. Aim, theory, pretest, other things. So here we will be interfacing 8051 microcontroller with the display device. Here it is LED and 7-segment display. So theory again details the same thing. Theory on LED and 7-segment display is also available over here. So now let's see interfacing with 7-segment display experiment demonstration. So we know the theory behind that. There will be 7 segments which we need to glow that to get the digit displayed on the 7-segment display, right? There will be two types, common cathode and common anode. So here we'll be using common cathode 7-segment display. So all the detailing will be there. This is how we need to get the output, and also the hexadecimal values to be used in the code is also available over here. So other downloads with respect to this particular experiment will also be available. So as I already told at the beginning, this virtual lab platform provides complete learning management system, complete LMS at a single point. So all the downloads with respect to one particular experiment will be available. Set PDF is available. We can click that and look into that. If not, in some of the experiments, the downloads will be available as a separate button over here. Okay, so we can go within that and access the contents. So we'll be having pre-test and post-test, that is set of questions to test our understanding levels. Then would be the procedure. So this procedure here, to repeat again, the procedure is to do the experiment in this virtual lab platform and not to do the experiment in the physical lab. Okay, this is with respect to the procedure. Then is the simulation. So now let's get into the simulation for this particular experiment. Okay, fine. So this is how the simulator is available. So what are the different things that is available for us over here? So here is a small editor where we can write our own code and execute that. If not, we can copy the sample code from somewhere, paste it over here and do the execution. Okay, to execute the code, we have three options, that is run, debug and reset. Here, the current line will be shown in the green color, next line in blue color and error in red color. So let me now take the sample code available. Here also it segment display. Interfacing diagram is given. So I'll copy the code and paste it in the editor available over here. So now I'll click on debug option for the step-by-step execution. So you can see the output over here. Here we can change the port we want to select according to the code. 0 is used, P0 is used. So port 0 we can select. If I select some other port and click on debug option, you'll be not getting the output over here. So let me keep back in port 0 only. Now this is to observe the memory mapping. So P0 of current line 6D has been loaded here. We can see the pin mappings. Yeah. So this is how the microcontroller lab experiment and the microcontroller lab is available in virtual lab platform. So we can take printout of this particular simulation window and keep it for a future reference. So this is how we'll be getting the screenshot of the window, which we can save it in a PDF format. So below will be the set of questions to test our understanding levels, which we can answer, submit it. So then we'll be getting the test in a PDF format. Okay. So this is how experiments available under microcontroller lab. So now let me stop sharing my screen. Okay. So can I have now one of the participants sharing the screen and doing one more experiment under microcontroller lab? And before that, yes, sir. Yeah, you can proceed. Before that, Veena ma'am, is the flash plugin unblock of is possible? Is it possible for you? Veena ma'am, can I get your response? Unblocking Adobe Flash Player, was it possible for you? Okay, no problem.
Ma'am, can you
Yes,
please
sir.
see the
Yes, we can see your screen. So you can go
yes,
with the third experiment. Yeah.
yes, ma'am. Ma'am, directly I'll go to the simulation.
Okay.
Here I'll copy the code from sample.
Okay. So this is a very simple code.
Mhm.
Yes. Okay. So yes, sir.
Ma'am, one just a moment. Ma'am.
Yes, sir.
It has taken the previous one, ma'am. Ma'am, how to erase this, ma'am, if I don't want this 4 lines?
No, it is similar to the editor what we have. So you can just click on the editor.
Editor,
You can
okay.
just select that and paste. Yeah, click the pointer on the editor.
Mm-hmm.
No, not over there. On the white screen, sir. Down
Okay.
below the other line.
Mm-hmm.
In that lining 1, 2, 3, 4. You can just select that all the 4 lines.
Yeah.
It is normal to our editor, notepad only. Yes, you can just paste the code.
Yes, ma'am.
Again, yeah, you can. Yes.
Yes, ma'am. Now
Yeah.
Do I need to select the pins, ma'am? Because
Now
here
it
it says
has
it is
been
port
selected.
0. Yeah.
Yeah. So it has been the correct port has been selected. If you change the ports in the code,
Yeah. But
then you
right now
can.
I'm choosing port 0 only. So
Okay.
directly I can go with the run, no, ma'am?
Yes, sir. Run option will do the one-time execution. You can click on debug option for the step-by-step execution.
Yes, ma'am. Yes, ma'am. I'm able to see the output, ma'am. Thank you very much, ma'am.
Yeah. Yes, sir.
Thank
So
you, ma'am.
basically here the code is, we can change the direction of the motor rotation. We can stop the motor rotation. Yeah, thank you, sir. You can stop
Thank you, ma'am.
sharing your screen now.
Sure, ma'am. Sure,
Yes,
ma'am.
sir. Fine. So, okay. Just a second. Yeah. So let me share my screen now. I'm in the main website. It is coming. So hope my screen is visible. Okay.
Yes, ma'am.
So currently I am in the main website now. Fine. So now let's see one of the experiments under electrical. Yeah. So people were asking about electrical machines lab. So there are 3 electrical machines lab available in the main portal. One is from IIT Guwahati, one from COE Pune, and one more from IIT Roorkee. Okay, so now let's see one which deals with a basic experiment. So in the afternoon, let's see one more. Okay, so let me take you with electrical machines lab from IIT Guwahati. To start with, I'll take you with this particular lab. So here are the experiments available from very basic to the advanced ones. So all the most of the labs what we come across in electrical engineering domain in virtual lab platform will have lot of connections to be involved. So to start with, I'll take you with the first example experiment only for the demonstration. Okay. So here if you see, it is to study the generation of magnetic field using AC as well as DC current. Okay. So here we have the introduction for this particular lab, then is the theory, then the procedure to perform the experiment over here. So if we quickly look into the procedure, here we have experiment 1 and experiment 2. That is, experiment 1 deals with the generation of magnetic field using DC current, and experiment 2 with AC current. Then other set of questions. Okay, so if we quickly look into the procedure, the other experiment will follow a similar procedure. So moving out of this virtual lab, if we take this particular experiment in the physical lab, what we will be doing? We will be energizing the coil, then we will be observing the deflection in the compass needle, right? Here, it is other than here, the compass will not be there. Instead of that, Hall sensor will be available, okay, in the experiment. So this again works with Adobe Flash Player. So I will first enable that. So this is the simulator window available. So let me move to the procedure first. So first we need to connect the terminals of coil with the power supply, then Hall sensor to the oscilloscope, then we need to check the connection. So here I would like to stress on one of the points. So wherever the connection is involved, if it is right or not. Okay, only once we get the right connection, then only we can proceed further. If not, the simulation will not continue further. Okay, so with this, let's get into the experiment. This is the simulation window that is available. So first step would be energizing the coil, right? So for that, I'll connect the coil to the supply. Next, I'll connect Hall sensor to the oscilloscope. Next step would be to check if the connection is right. Here, this is a simple connection. So we got the connection is right. Next step, according to the procedure, is turning on MCB. So we need to click over here. Okay. So once we turn on MCB, I'll not change polarity. I'll just change the magnitude over here. Yeah. So once you increase the magnitude, you can see the flux lines, poles, the mathematical representation, also the current direction. So now if we change the polarity, all these things changes. So we can see the change in waveform, the poles and the current direction as well. Okay, so this is one of the basic experiment demonstrated under this electrical machines lab from IIT Guwahati. So experiment 2 will also have a similar interface. Only the exception is here we'll be having 2 knobs instead of one for frequency and one more for voltage. Okay, so to quickly go with the procedure, the connection would be similar. We need to connect the coil, connect Hall sensor, check if it is right, then turn on MCB. I'll not change the frequency, I'll just increase the amplitude or the magnitude, so we can see the variation with respect to the AC input. Yeah. Now if we change the frequency, if we increase the frequency, we can see the change in variation with all the parameters. Yeah. So this is one of the basic experiment that is demonstrated under electrical machines lab. So now okay, now the IIT Kharagpur labs are up. Fine. So let me go back to the main website now. So I think we have 10 more minutes for the now the connection is my voice is not clear now. Hello. It is clear, right? Okay, sir. Thank you. Fine. Okay, so now we are almost moving towards the end of morning session. So let me quickly demonstrate one of the lab now. Then we'll, if anybody have any of the questions, we will clear that and we will wind up the session for morning and we'll all get back at 2. Okay, so I'm in the main website now. Hope the screen is visible. Now, as I already told, let me take you with one of the experiment under computer science and engineering domain that is more relevant to us. Okay, so there are different labs available. Let me now take you with computer architecture and organization lab from IIT Kharagpur. Okay, so all the contents covered would be similar. So let us directly get into the list of experiments. So if you observe over here, so there are a couple of experiments under logic design, right? So when we say logic design subject or digital electronics subject, there are many labs available in this virtual lab platform, especially under electronics and communication domain. Okay, some experiments might be repeated with different interfaces, some might be different experiments. Okay, but an example like an experiment for K-map, which you can see over here, last but one, is available only in this particular lab, that is under computer architecture and organization lab in CS, computer science and engineering domain in virtual lab platform. Okay, so if we go within that, this particular experiment is operable in our cell phones as well. So again, all the contents covered, I'll go to simulator directly. Okay, so here we have objective, procedure, then the experiment. This one, some of the experiments will also, okay, so the simulator available. To access this, need to click on this blue screen. Okay, so once we click, okay, it is taking time. We just need to click on blue screen actually. Yes. So this is the simulator interface that is available for KMap. Okay. So what are the different options available? So here we can select the number of input variables that is required. So we have an option up to 8. So we can have a 6 variable KMap now. So here we can allow don't care to be present, or we can set it for no. We can hide the result initially. So for the students, so if a question has been given in the assignment, if they have any doubt in grouping or so getting the expression, just come over here, solve the given question using pen and paper, and compare their results by coming over here. Okay. So first initially they can hide the result. We can hide the result. We can set manually. So I have hide it don't care now. Like I have not allowed the don't care to be present. So if we just leave it, it is 0. If we click once, the cell values turns to 1. Okay. So if I allow don't care to be present, if I keep allow don't care as S, then this cell will reset. So whatever thing you need to select over here, you need to do before you proceed with the experiment. Okay. So now I have made don't care as S. So to have the don't care in one of the cells, I need to click twice. Okay. If I click once, I'll be getting 1. If I click twice, X will come. So similarly, we can fill up the cell according to our requirements. Then solve it using pen and paper. Then once we get the answer, we can unhide the result. We'll be getting the grouping over here as well as the expression. Fine. So I think with this, let us now, I'll stop sharing my screen. Fine. Could you please explain load test on DC motor, induction motor? Yes, sir. So other than the lab demonstration, whether anybody have generalized questions or doubts so that we can clear over here on virtual labs?
Excuse me, madam. I'm Dr.
Yes.
Sasmita from NITK College.
Yes, ma'am.
Actually, madam, as you told, there are no lab for communication experiment. Communication lab, there
Yes.
are no, you don't have. So,
Yes,
but in Amrita Vishwavidyalaya, you saw there that they have some passive and active components.
Yes, ma'am.
Where if we have the circuit diagram, then we can pick all those components and do. So
Yes,
can you suggest me in some institute they have certain lab where we get CRO, signal generator, and the passive components together, so that if we have the circuit, we can only do it for communication lab.
Okay. Got it, ma'am. Components there are available, but you're telling with respect to communication, if we can dig up.
All the components, like we need basically signal generator, CRO,
Got
and
it,
the
ma'am.
passive
Yeah.
components and active components. If certain lab is there which comprises of all the components, we can only give the circuit and we can.
Currently, there is no lab as such, ma'am.
Okay.
Yeah, so basically, as I already told here, there is no option for the customization. So what has been developed, that is there. So this idea is good. So you can keep it, and we can develop a lab in the idea what you have told. So lab development is possible, but with the current availability, such modifications are not.
Madam, one more question. Can we do the lab development from our side if we want? We want to
Yes,
develop.
ma'am. Yeah, so the nodal centers actually can develop the labs.
Okay.
So that's what, but that is again a different procedure, and that is a long procedure. So it is not, lab development is not a very easy or very quick process. So it has to undergo, first the proposal has to be done, then it has to be approved by the national team.
Okay.
Then the training has to be given with the flow. Then you can develop the labs.
Okay.
So once you develop labs, so for example, if you are a nodal center, if your college is a nodal center,
Yeah.
then you apply, like you propose a lab development.
Okay, madam.
In that case, if the proposal is approved, you got the idea also how to develop. Once you develop the lab, that has to be submitted to the participating institute to which you are entitled with. So for example, if now you are a nodal center under NITK Surathkal, so the lab developed by you has to be approved by NITK Surathkal and also by the national team. Then only it will be added to the virtual lab platform.
Okay, understood.
Yeah, so
But,
all the labs, and also there are multiple rounds that has to be that each lab has to undergo, each experiment has to undergo. Only then it will be added to the main portal.
So for this, we have to apply through the nodal center, our college nodal center, to the
Yes,
to the
ma'am.
concerned person in NITK Surathkal, right?
Yeah, so basically in your college there will be a nodal coordinator.
Yeah, sister.
Yes, so through him you can write a mail to Solve ID or so, our official mail ID. Hello.
Yeah, ma'am.
Yes, ma'am. Yeah, then the procedure goes. So first thing would be like that's what. This is the familiarization about the platform. Then would be the outage. Like actually, as I already told, individual simulator or individual lab have unique type of simulator interface.
Exactly.
Also the different experiments available. So first thing would be finding out the gap areas.
Yes.
Yes. Then would be the next steps. And okay, other questions? Yes, for electrical. Yeah, okay, ma'am. Thank you. So other experiments that is on electrical machines or so will be demonstrated in the afternoon session, sir. Demonstration on electrical machines, digital signal processing, logic design, other labs, everything will be demonstrated in the afternoon session.
Hello, ma'am.
Yes, yes, ma'am.
Ma'am, we don't have login credentials in virtual lab like IIT Kharagpur. So then what to do? How to access?
The labs developed by IIT Kharagpur will not require any login to like for the simulators to use the simulators developed by IIT Kharagpur or so will not ask login when you try to access a simulator. Only with the labs developed by IIT Kanpur and Amrita Vishwavidyapeetham will ask for login when you try to access the simulator. So you can just create your account over there.
So freely we get
you can just yes, ma'am.
Can we get free login credentials, ma'am?
Yes, ma'am. Yeah. There is an option to create your account as well, site login option.
Means we have to register in that.
Yes.
Okay.
Yeah.
Okay. Free registration.
Yes, ma'am.
Okay, ma'am. Okay. Thank you, ma'am.
Yeah.
Madam,
yes, sir.
Madam, there are some costly instrumentations like in RF we have to deal with high frequencies and
yes, sir.
some of the other things are there, very costly equipments, labs, because that is where the problem will arise because small instruments will be available in all the colleges. For example, beta, multimeter, and some CROs, all will be available in all reputed colleges.
Yes.
And, in IITs, there are some facilities. Can we access those facilities is my concern. Can you give a light on it, please?
Yes, sir. So in virtual lab, that's what under simulation, there is one lab for RF and microwave engineering in electronics and communication. I think that is currently down because of some upgradation. You can access it later on whenever required. If not, other than that, as what you were mentioning, that the costly equipments might be available in IITs or so. Can we access that? To answer for that, currently that is what is called remote triggered lab. That was what KVG sir initially in the first session he was showing an experiment on simple pendulum, right? So that is basically your work operating the actual real experiment that is in NITK Surathkal or say IIT Delhi also. But remote triggered lab is not available in all the institutes. Remote triggered lab, when we say if you want to access the experiment, yes, sir. Yeah.
Yeah. Yeah. Yeah. Okay, sir. Thank you. Thank you for your. Yeah, sir. Oh, definitely, sir. Thank you. Thank you for the query.
Yeah, thank you, Beryl, sir.
Yeah. Thank you.
Yes, sir. And few, yeah. So in the afternoon session, we'll try to demonstrate few more labs with the core labs. Other than that, on DSP, other electrical machines and all, there will be many more demonstrations to be coming in the afternoon session. Now the session is for break. Yeah. If not, if we cannot demonstrate any of the labs, then we request you to explore and come up with the queries at a later point. Okay. Other than that, regarding final year students, a question on that Fatima ma'am had asked for. So, as an internship part, they can come to NITK Surathkal, be with us for 2 months or so, and join in developing labs. So, we will train them in the lab development, and that could be their internship activity.
Will you give certification?
So, once they complete the internship for 2 months, we will be providing them the certificate.
Okay.
Yes, sir. So maybe more information regarding that we can tell in the afternoon. We can discuss in the afternoon session as well if there are any further queries. So now the time is 12:38. So now the session is for lunch break. So thank you all. So we request you all to join back by 2. So we'll start the session at sharp 2 and proceed further. Okay. So with this, let's wind up the session after morning. Thank you. So we request all
Madam,
the participants.
is it the same meeting ID or meeting ID?
Same meeting ID, ma'am. So same meeting ID, same YouTube link. So we will all meet by 2. Thank you.